Good evening and welcome back. Wherever you happen to be right now, whatever kind of day is finally settling behind you, I'm glad you found your way here. There's nothing you need to do tonight. No part of this you have to follow closely. No thread you have to keep hold of. You can let your attention drift and sink and wander off and return whenever it likes, and you'll miss nothing. Because the whole point of this slow journey is to let the mind loosen while it listens. Tonight we're going to think about something that sounds, at first, almost simple. A question a child might ask and an adult might assume has already been answered. Why has no one ever reached the deepest point inside a volcano? We have walked on the moon. We have sent machines past the edge of the solar system, out beyond the planets, into the dark between the stars. We have lowered submersibles to the very floor of the deepest ocean trench, nearly 11 kilometers down into the crushing black. We have drilled holes into the crust of the earth, deeper than the tallest mountains are high. And yet, for all of that reach, for all that restless human appetite to go where nothing living has gone, no person has ever descended to the heart of a volcano. No one has touched the place where the fire is born. We have stood at the rim. We have leaned over the edge and looked down into the glow. But the deepest point, the true interior, remains closed to us, as it has always been, as it may always be. Before we begin to wander into that question, I wonder where you're listening from tonight. Is it dark where you are? The house gone quiet? The day folded up and put away? Or is it the pale beginning of a morning somewhere? The light still soft and uncertain at the edges of the window. It's a strange and lovely thing that we can lie still in our own small warm corner of the world and send our thoughts down into something so hot and so hidden, into a place that no eye has ever truly seen. If you find this kind of slow exploring soothing, you might let the channel know with a quiet like, or stay with us a while by subscribing, and that helps others who are looking for something calm to drift off to find their way here as well. But only if it feels right. There's no hurry tonight, and there never is. So let's begin the way we always do, gently, without rushing, letting the picture build itself a piece at a time. Because to understand why no one has reached the deepest point inside a volcano, we first have to let go of the idea most of us carry of what a volcano even is. The picture we inherit as children, the mountain with a hole in the top, smoke curling out, and somewhere far below, a great glowing chamber full of liquid fire. Like a cauldron, the earth keeps simmering, a hollow cone with a furnace at the bottom, waiting. It's a beautiful image, and it sits deep in the imagination, but it is almost entirely wrong. And the ways in which it is wrong are exactly the reasons no one can ever climb down inside. Let's take that mountain apart in our minds, slowly, and see what is really there. Picture a volcano from the outside first. The familiar shape, the broad sloping sides rising to a summit, and at the summit, a crater, a bowl or a pit where the rock falls away. That much of the old picture is true enough. There is often a crater, sometimes wide and shallow, sometimes a deep, steep shaft, and at the very bottom of some of them, in only a handful of places on the whole planet, there is indeed something molten, something that glows. But that crater is not the inside of the volcano. It is more like a mouth. The inside, the real interior, the part the old picture imagines as a hollow chamber, is not hollow at all. It is solid rock, dense, heavy, unbroken rock, kilometer after kilometer of it, and threaded through that rock, in narrow cracks and pipes and pockets, is the molten material we call magma. Not a lake in a cavern, not an open sea of fire with air above it that a person could descend toward, something far stranger and far less welcoming to a body made of skin and bone. Imagine instead of a hollow cone, a tree. Above the ground, the trunk and the branches, the part you can see and touch. Below the ground, spreading out and reaching down, the roots, narrowing and dividing as they go deeper, finding their way through the soil. A volcano is more like that tree than like a chimney. What you see at the surface, the mountain, the crater, the vent, is only the top of a vast and mostly invisible structure that reaches down through the entire thickness of the crust, kilometers and kilometers into the earth, branching and narrowing, and connecting to deeper reservoirs. All of it embedded in rock, all of it under enormous pressure, all of it hot beyond anything in our ordinary experience. The fire does not sit in a room waiting for a visitor. It moves through the solid body of the planet, like sap moving through wood, and where it gathers not in open caverns, but in zones where the rock itself has partly melted, a mixture of crystals and liquid, more like a sodden sponge than a pool. This is the first thing to understand, and the most important, so let's stay with it a moment longer, because everything else follows from it. There is no door, there is no shaft leading down to a chamber you could stand in. The deepest point inside a volcano is not an empty space at all. It is a place where rock and melt are pressed together under the weight of the world, where there is no air, no room, no surface to descend toward. Even if heat were no obstacle, even if a person could somehow not burn, there would be nowhere to go. You would be trying to walk into stone. The interior of a volcano is, in the most literal sense, full, and you cannot enter what is already completely occupied by the substance of the earth itself. For almost all of human history, of course, we pictured it very differently, and it's worth pausing on that older picture, because it lived in the imagination for thousands of years, and some of it lingers in us still. To the people who lived in the shadow of these mountains, watching them glow and tremble and pour out fire, the volcano was not a structure to be understood, but a presence to be feared and honored, a place where the human world touched something older and hotter and stranger than itself. The very word we use, volcano, comes down to us from the Romans, from the name of their god of fire and the forge, who they believed kept his workshop beneath a small island that smoked and rumbled off the coast of Italy. When the mountain glowed at night and the ground shook, it was the god at his anvil, hammering out the weapons of the other gods, the sparks of his labor rising through the mouth of the mountain. The Greeks before them had told much the same story of their own fire god, lame and brilliant, working at his forge in the dark beneath the earth. And across the world, in the islands of the Pacific, the fire of the volcano was understood as a goddess living in the crater, passionate and dangerous, her moods written in the rising and falling of the lava, and the people brought her offerings and told her stories, and treated the glowing pit with the respect you would give to a living power. And in the long centuries of the European Middle Ages, the volcano took on a darker meaning still. The mouth of a burning mountain, breathing smoke and fire, became in the imagination a doorway to the underworld, an entrance to the place of punishment, a hole that led down into the regions of the damned. The great smoking mountains of the south and the fiery peaks of distant Iceland were spoken of as gates through which the lost descended, and from which, on the worst nights, their cries might rise. To stand at the crater rim was to stand at the threshold of the world below, and to fall in was to fall out of the world of the living altogether. The fire at the bottom was not molten rock, it was judgment. What runs through all of these old stories, the forge and the goddess and the gate to the underworld, is the same instinct that gives us the childhood picture of the hollow mountain. The sense that the volcano is a way in, a passage, a connection between our world and another, deeper, hotter one, with a chamber or a realm at the bottom that could, in principle, be entered if only one were brave enough, or doomed enough, or more than human. And much later, when the gods had faded from the explanation, this same instinct gave us the great adventure stories of descending into the earth through a volcano, of climbing down a crater into a vast hollow interior, traveling through enormous glittering caverns toward the center of the world, and rising again at the end on a column of lava through the mouth of another burning mountain far away. It is one of the most enduring dreams we have, this dream of the volcano as a road downward, into the secret inside of our own planet. But it is a dream, and the truth, as we are slowly seeing, is both less and more. There is no road downward. There is no hollow interior, no cavern, no chamber, no realm. There is only the solid, hot, full body of the earth, and the fire moving through it in cracks too fine to enter, and the door that the old stories imagined has never once, in all the long ages, stood open to anything that wished to go in. That alone would be enough to close the question. But the truth is so much richer than that, and the closer we look, the more reasons appear, layer upon layer, each one its own kind of barrier. So let's keep descending in our imagination, slowly, the way you might let yourself sink toward sleep, and look at each of these barriers in turn. Let's start at the top, at the only part of the inside that any human being has ever actually seen with their own eyes. The crater floor, the lava lake, the surface of the molten world. There are, on the entire surface of the Earth, only a very small number of places where the molten interior comes close enough to the surface and stays there long enough to form what we call a persistent lava lake. You could count them, at any given time, on your fingers. They are rare because the conditions that allow them are delicate and unusual. The magma has to rise high in the conduit and sit there, churning, kept liquid by a constant slow exchange of heat and gas, neither draining away nor erupting violently, just simmering in an open pit, year after year, decade after decade. It is a kind of accident of geology, a balance held for a long time, and it is the closest thing on Earth to a window looking directly into the molten interior. There is one in the Democratic Republic of the Congo, on a mountain whose name has a soft heaviness to it, Nyiragongo, where one of the largest lava lakes in the world has come and gone over the years, sometimes filling the crater with a vast glowing surface hundreds of meters across. There is one far to the north, in the Danakil Depression of Ethiopia, one of the hottest and lowest and most desolate places on the planet, on a low, broad volcano called Erta El, which means, fittingly, the smoking mountain. There is one on the floor of a crater on the island of Ambrim in the South Pacific, in the nation of Vanuatu, a place called Marum, where the lava lake sits at the bottom of an enormous ash-walled pit. There is one beneath the ice of Antarctica, near the bottom of the world, in the crater of Mount Erebus, a lake of strange, rare lava that has glowed in that frozen silence for as long as anyone has watched it. And from time to time others appear, in Hawaii, in Nicaragua, in the islands of the southern oceans, wherever the conditions align for a while before they shift again. Each of these few lava lakes has its own character, its own face, and it's worth letting them become individual for a moment rather than a list, because they are among the most extraordinary places on the surface of the world, and almost no one will ever see them. Nyiragongo, in the heart of Africa, holds a lava unlike almost any other, so poor in the silica that usually makes molten rock thick and slow, that it runs thin and fast, like a dark hot water. This is why its lake can grow so vast and so smooth, and it is also why the mountain is so feared by the people who live in the city at its foot. More than once in living memory, the crater has cracked open near its base, and the lake has simply drained away, the molten rock pouring downhill in fast-moving floods that race across the land faster than a person can run, reaching the city below, swallowing roads and homes. A lava lake that elsewhere would be a slow and stately thing is here a reservoir of liquid fire perched above the lives of many, held in by a crater wall that has failed before and will fail again. To descend into that crater, as a very few have done, is to lower yourself toward one of the most dangerous bodies of molten rock on Earth, beautiful and treacherous in equal measure. Erta Ale, in the Danakil, sits in a place that is itself almost beyond belief, one of the hottest inhabited regions on the planet, a low sunken desert of salt and sulfur where the air shimmers and the ground crackles underfoot. The volcano is a broad, low shield, not a towering cone, and in its summit pit a lava lake has churned for a very long time, one of the longest lived on Earth, glowing through the desert nights in a place so remote and so harsh that simply reaching it is an expedition. There is something fitting in that, a persistent window into the molten interior, kept in one of the few places forbidding enough that it has stayed mostly undisturbed, breathing its heat into a landscape that already feels like the inside of a furnace. Mount Erebus, at the far other extreme of the world, holds its lava lake in a setting of ice and silence. on an island in the frozen sea near the bottom of the planet, surrounded not by desert heat, but by glaciers and the strange hollow towers of ice that form where the volcano's warm breath escapes through the snow and freezes around the rising steam. Its lava is rare and unusual, and its lake has glowed in that white solitude for as long as anyone has kept watch, one of the most remote, persistent lava lakes there is, a point of fire at the bottom of a continent of ice, a contrast so complete that it hardly seems possible both could exist in the same world. And there have been others, coming and going as the conditions allow. In Hawaii, a great lava lake filled a crater for a decade and more, a famous glowing presence, before draining away in a dramatic collapse and later rising again, the lake breathing with the volcano beneath it. In Nicaragua, there is one reachable almost by road, a crater the early colonizers called the Mouth of Hell, where you can stand at a railing and look down into the molten surface as if visiting a viewpoint, which lends the whole thing an air of the ordinary that the heat and the gas very quickly dispel. Each of these is a place where the interior, for a while, comes up to look at the sky, and each of them, every single one, marks not the inside of the volcano, but only its surface, only the topmost skin of the molten column, only the threshold we keep returning to, the place where the unreachable interior briefly shows its face before sinking back into the dark. But here is something easy to forget when we picture volcanoes as mountains standing on land. Most of the fire of the Earth never breaks the surface where we can see it at all. The great majority of the planet's volcanism happens underwater, hidden beneath kilometers of ocean, along the vast ranges of undersea mountains that wind around the globe like the seams of a great ball, where the plates of the crust pull apart and new rock wells up to fill the gap. Down there, in the cold dark of the deep sea, molten rock meets the water and is quenched into strange rounded shapes, pillow after pillow of fresh black glass, and hot mineral-laden fluids rise through chimneys that build themselves from the dissolved earth, the famous dark smokers, around which whole communities of life have gathered in the lightless depths, living without any sun at all. And here, strangely, is where we have come closest of all to watching the molten interior emerge, not because the deep sea is gentle, but because the water changes everything. The immense pressure of the ocean suppresses the violent explosions that make eruptions on land so deadly, and the water cools the lava almost the instant it appears, so that small submersibles carrying scientists have descended to these ridges and hovered close, very close, to vents that were actively building new seafloor, have even at times come upon fresh glassy lava only just erupted, still warm, the newest rock anywhere on the planet. We have watched the Earth make itself, down there in the dark, from a few meters away, through the thick window of a deep submersible, and yet even there, even at that astonishing nearness, the same boundary holds. The submersible hovers above the new rock, beside the vent, near the place where the magma reaches the sea. It does not enter the vent. It does not descend the conduit. It touches the threshold and goes no further, because below the place where the magma meets the water lies, once again, the solid, hot interior that has no room for anything to enter. The ocean has let us come closer to the emerging fire than the land ever has. It has not let us in. To stand at the rim of one of these, looking down, is to stand at the very edge of what is humanly possible, and to feel, in your whole body, why it is the edge. Let yourself imagine it for a moment. You have walked for hours, sometimes days, across hardened lava and loose ash and bare volcanic rock to reach the crater rim. The ground beneath you is the cooled skin of old eruptions, sharp and black and strange, ringing faintly under your boots. And then you come to the edge, and the world simply ends, falling away into a pit, and far below, at the bottom of the pit, there is light, not reflected light, light that comes from the thing itself, a great restless surface, the color of sunset and embers, and the inside of a furnace, dark crusted plates drifting across it like ice flows on a river, splitting apart to show the brighter orange beneath, the molten rock sliding and turning and folding back into itself, slow and immense and alive. And the heat reaches up to you even there, even hundreds of meters above it, a warmth on your face that has nothing gentle in it, a reminder rising on the air. That is the surface of the deepest accessible part of the inside. And here is the thing worth sitting with. Even that, even just reaching the rim and looking down, is already near the limit. A small number of people have gone further. They have descended into the crater itself, rappelling down the unstable walls, lowering themselves on ropes into the pit, dropping below the rim and down toward the lake. And we'll spend some time with them, with what they found and how far they got, and why they could go no further. But notice already, before we even climb down, that the deepest point a human has ever reached inside a volcano is not somewhere in the magma chamber, not somewhere in the conduit, not somewhere deep in the roots of the mountain. It is the floor of an open crater, beside the lava lake, at the very top of the whole structure. The interior proper, everything below that glowing surface, has never been entered by anyone, and as we go on, it will become clear that it never could be. We have only ever reached the threshold. We have only ever stood in the doorway and felt the heat of the room we cannot enter. Let's go down into the crater now, in our minds, and join the few who have made that descent, because their experience tells us so much about the barriers, and because there is something hypnotic in the slowness and care of it, the way every movement has to be deliberate, the way the body has to be coaxed downward against everything that tells it not to go. The descent into an active crater begins, strangely, with patience. You do not simply walk in. The walls of these craters are rarely solid. They are made of layered ash and cinder and broken rock, the debris of past eruptions, piled steeply and held together by little more than friction and time. To put weight on them is to set them moving. So the first part of the journey down is a slow negotiation with loose ground, testing each placement of a foot or a hand, sending small avalanches of rubble cascading into the dark below, listening to them clatter and fade. Ropes are anchored to whatever can be trusted, and there is often very little that can be trusted, and the descent becomes a long suspended hanging in the air against the inner wall of the pit, turning slowly, the rope your only connection to the world above. And there is a particular feeling, the explorers say, in that long hanging descent, a feeling the body does not like and never gets used to. You are going down into a place every instinct tells you to flee from. The light below is the color of danger. The heat reaches up to meet you. The walls are loose and shifting, and the deeper you go, the more the ordinary world recedes. The circle of sky above shrinking to a small bright disk, the daylight thinning, until you hang in a reddish gloom between the closing walls of the pit, the cool blue world sealed away above you, and the glowing world waiting below. Sound changes too. The wind and the ordinary noises of the surface fade, replaced by the deep sounds of the crater, the rumble and hiss rising from the lake, the clatter of dislodged stones falling away into the dark beneath your feet, the creak of the rope, your own breath loud inside the mask. Time stretches. Each meter is a small decision. There is no rushing it, no hurrying past the danger, because the danger is the whole environment, on every side, all the way down. You descend at the pace of caution, which is slow, which is patient, which is the only pace the place permits, and the descent that looks so brief from above unfolds, in the living of it, into a long suspended hour of careful movement toward the fire. And all the while, the ground you came from is doing what loose volcanic ground does. Stones work free above you and fall. Ledges crumble. The crater is not a fixed and finished place, but a thing in constant slow collapse, shedding itself inward, rebuilding the slope of rubble at its base from the ruin of its walls. To descend into it is to descend into something that is, very gently and very surely, falling apart around you, and to know that the same forces that loosen a stone above your head could, with no warning at all, loosen the ledge beneath your feet. This is why so few have done it, and why those who have speak of it with a particular quiet respect. It is not a place that wishes you harm. It is simply a place with no provision for your safety, indifferent to whether the next handful of rock holds or gives way, and you go into it knowing that, accepting it, lowering yourself anyway toward the only direct view of the molten interior that the earth allows. And as you go down, the conditions change with every meter. It grows hotter, of course, but not steadily, not predictably. The heat comes in waves, depending on the gases, depending on the wind that swirls inside the crater, depending on the mood of the lake below, and the air changes. This is the part that is easy to forget when we imagine these places from the safety of distance. The crater is not just hot. It is full of the breath of the volcano, and that breath is poison. We'll come back to the gases properly in a little while, because they deserve their own slow consideration. But for now, as we descend with the explorers, simply notice that the air itself becomes an enemy. The lower you go, the more concentrated it becomes. This invisible exhalation rising from the molten rock, and so the explorers go down wearing masks and carrying their own air, sealed against the very atmosphere of the place, because to breathe freely there, even for a few breaths, can blind you, can burn your lungs, can drop you unconscious before you understand what is happening. They descend into a pit where the air would kill them, toward a lake that would incinerate them, on walls that could collapse beneath them, and they do it slowly, meter by meter, because there is no other way. There was a man who made such a descent into the Marum crater on Ambrim, lowering himself all the way down to a ledge near the edge of the lava lake itself, closer than almost anyone had been, close enough to feel the radiant heat as a physical pressure against a protective suit, thus close enough to hear the lake. And that is one of the details that stays with you when you read the accounts of these journeys. The sound. From a distance, a volcano can seem silent, a slow glow in the dark, but up close, at the edge of the lake, it roars and hisses and cracks and booms, the molten rock surging and bursting, gas escaping in great gouts, the crusted plates grinding against one another, a constant overwhelming noise like a storm and an ocean and a furnace all at once, with no pause in it, no rest, the sound of the Earth's interior breathing through an open wound in its surface. And even there, even at that closest point, the man stood beside the lava, beside it, not on it, not in it. There is no on it, there is no in it. The surface of the lake is the absolute boundary, the place where the accessible world stops, and below that surface lies everything we are trying to reach tonight, and it lies behind a wall of pure heat that no living thing and no made thing has ever passed. So let's turn now to that wall, because it is the most fundamental barrier of all, the one that would remain even if everything else were solved, and it is worth understanding it not just as a number, but as a feeling, as a fact about the world. The molten rock in a lava lake is somewhere around 1,000 degrees, often more. The most fluid kinds, the dark basaltic lavas like those at Niragongo and Erta Ale, can be 1,100, 1,200 degrees and beyond. Numbers like that slide off the mind. They are so far outside anything we ever touch that they stop meaning anything. So let's bring it closer. Water boils at 100 degrees, and you know what boiling water does to skin, how even the steam above it can scald, how you flinch from a kettle. Now imagine something more than 10 times hotter than boiling. An oven in a kitchen reaches perhaps 250 degrees, and you would not put your hand inside it for a single second. The molten rock is 4-5 times hotter even than that. It is hot enough to melt most metals. Steel itself, the substance we build our strongest machines from, begins to soften and lose its strength at these temperatures, and would slump and fail and melt if held in molten rock. There is no fabric, no suit, no material a human could wear or carry that would protect a living body submerged in it, because the body would not merely be burned, it would be flash heated, the water within it turned instantly to steam, in less time than it takes to feel pain. But here is the part that truly seals the barrier, the part that makes even approaching impossible, let alone entering. You do not have to touch the lava to be killed by its heat. Heat travels through the air as radiation, the same way the warmth of the sun crosses the empty cold of space to reach your face on a clear day. And the radiant heat coming off a lava lake is so intense that it becomes dangerous from many meters away. Stand too long at a certain distance, and your clothing begins to scorch. Your exposed skin reddens and blisters. Your equipment fails. This is why even the boldest explorers, in their protective suits, can only remain near the lake for short stretches before they must retreat, before the heat soaking into them outpaces their ability to shed it. The volcano defends itself with a field of pure radiance, a heat that reaches out and pushes you back before you ever arrive. You cannot walk into it any more than you can walk into the sun. The closer you come, the harder it pushes, and well before you reach the molten surface, the pushing becomes lethal. So already, before we have gone a single meter below that surface, we have two absolute barriers. The interior is solid, there is nowhere to go, and the interior is hot beyond all survival, with a heat that kills at a distance. Either one alone would end the question. Together they make the deepest point inside a volcano, one of the most thoroughly closed places on the entire planet, more closed in some ways than the bottom of the ocean or the surface of another world, because those at least are spaces a protected body could occupy, and this is not a space at all. And yet there is more, because long before the heat or the solid rock stops you, the air itself may have already done so. Let's spend some time now with the breath of the volcano, the gases, because they are perhaps the most underestimated danger, and because there is something quietly fascinating in the chemistry of that hidden atmosphere. When we think of volcanic danger, we think of lava, of the slow glowing rivers, of the fountains and the bombs of molten rock thrown into the air. But the lava is, in a strange way, the honest danger, the one you can see and avoid. The gas is the hidden one, the silent one, and it has killed far more cautiously and more often than most people realize. As magma rises toward the surface and the pressure on it drops, the gases that were dissolved within it, held under pressure like the fizz held in a sealed bottle, come out of solution and escape. This is, in fact, much of what drives an eruption in the first place, the violent release of trapped gas. But even in the quiet times, even at a simmering lava lake, this exhalation goes on continuously, a steady breathing out of the deep chemistry of the planet. What comes out is a mixture, and it changes from volcano to volcano, but the main components tell their own story. There is water vapor, the most abundant, which sounds harmless until you remember how hot it is. There is carbon dioxide, invisible, odorless, heavier than air. There is sulfur dioxide, with its sharp, choking smell, the smell people often describe as the smell of a struck match or of rotten eggs gone metallic. There is hydrogen sulfide, hydrogen chloride, hydrogen fluoride, a whole alphabet of acidic, corrosive, suffocating compounds. Breathed in, these gases attack the lungs directly. They react with the moisture in your airways to form acids, burning the delicate tissue from the inside. Even small concentrations cause coughing, streaming eyes, a tightening in the chest. Larger concentrations can fill the lungs with fluid and drown a person in open air, hours after exposure, when they thought they had escaped. And the carbon dioxide deserves a special, quiet kind of attention, because it kills in the most insidious way of all. It is heavier than the air around it, so it does not rise and disperse. It pools. It collects in the low places, in the bottoms of craters, in hollows and pits and depressions, forming invisible lakes of suffocating gas where the ordinary air should be. You cannot see it. You cannot smell it. There is no warning. A person can walk down into a dip in the ground, into a crater floor, into a hollow that looks perfectly ordinary, and step without knowing it into air that has no oxygen in it at all, and simply lose consciousness and never wake. In volcanic regions, there are places the local people have long known to avoid, killing fields where birds fall dead from the sky and animals are found lying as if asleep, places where the earth breathes out its silent, heavy breath, and anything that lingers there dies. To descend into a crater, then, toward the deepest accessible point, is to descend into a basin where this invisible danger collects, into the very lowest part of the landscape, exactly where the heavy gas gathers thickest. The geometry of the place conspires against you. The closer you get to the bottom, the worse the air becomes, until near the lake, the explorers move through an atmosphere that is barely an atmosphere at all, sealed in their suits, breathing from their tanks, surrounded by a tide of poison they cannot see. So now we have a third barrier woven through the first two. The interior is solid, the interior is unbearably hot, and the way down passes through air that suffocates and burns. 3 reasons, each sufficient on its own, and we have still not gone below the surface of the lake. We are still standing, in our imagination, at the absolute frontier, at the rim of the molten surface, having reached the deepest point any human ever has, and beyond it lies the true interior, which we will now try to understand, even though we can never enter it, by following the path the magma takes, downward, into the body of the mountain and into the earth beneath. What lies directly below the surface of a lava lake? This is where the old hollow mountain picture finally falls apart completely, and where the real structure becomes both stranger and more beautiful. Below the glowing surface is more molten rock, of course, a column of it, filling a roughly vertical passage we call the conduit. This is the throat of the volcano, the pipe through which magma rises from the depths to the surface, and in the rare quiet volcanoes with their persistent lakes, that conduit is, near the top, genuinely full of liquid rock, churning and convecting, hotter material rising and cooler material sinking, in a slow, endless circulation that keeps the lake alive. You might imagine, then, that if you could somehow survive, you could descend through this liquid column, down and down through the conduit, toward whatever lies at its base. But the conduit is not an open well of liquid all the way down. It narrows, it twists, and crucially, in almost all volcanoes, for almost all of their lives, it is not open at all, but plugged, sealed, choked with rock. The persistent lava lakes are the exception, not the rule, and even in them the liquid column gives way, somewhere below, to a different state. As you descend in imagination through the conduit, the pressure rises with every meter, the weight of all the rock and magma above pressing down, and the character of the material changes. The cleanly liquid rock near the surface becomes, lower down, a thicker, stiffer, more crowded substance, more crystals and less melt, a mush, and then below that the cracks through which magma travels grow narrow and intricate, a web rather than a pipe, and the idea of a single descendable passage simply dissolves. There is no straight shaft to the center. There is a branching, narrowing, tightening system of fractures and channels, most of them no wider than a hand or a finger or a hairline crack, threaded through solid rock that has never been a cavern and never will be. And between eruptions, between the active phases, even the main conduit seals itself. The magma that filled it cools and hardens into a plug, a column of new solid rock, welding the volcano shut from the inside. This is why volcanoes can sit silent for years, for centuries, for thousands of years, and then erupt again. The plug is not a permanent closure, it is a temporary one, and pressure builds beneath it until it fails. But while it holds, the throat of the volcano is not a passage at all. It is filled stone, indistinguishable from the rock around it except in its history. To descend the conduit of a sleeping volcano, you would not be swimming down a column of fire. You would be trying to tunnel through solid rock that happens to have once been molten. The way down is closed, sealed by the same fire we are trying to reach, which cools and locks the door behind itself every time it retreats. This is one of the quiet ironies of the whole matter. The fire makes its own prison. The magma that rises and might, in fantasy, offer a path downward, is the very thing that hardens into the barrier blocking that path. The volcano is sealed by the substance of the volcano. There is no moment when the door is open, because the moment the door would be open is the moment of eruption, when the conduit clears and the magma rises and bursts out, and that is the one moment of all moments when no living thing could possibly be inside it, descending against the outrush of fire. The door opens only outward, only violently, only in the direction of escape, never inward, never toward the depths, never for a visitor. You might object, here, that people do go inside volcanoes, and in a sense you would be right. So let's follow that thread for a while, because it leads somewhere revealing. There is a kind of cave that forms in volcanic country, and exploring it is, in the most literal sense, going inside a volcano. When fluid lava flows downhill in a channel, the surface of the flow, exposed to the air, cools and hardens into a crust, while the molten rock beneath keeps moving, and over time, that crust can roof the channel over entirely, forming a pipe of hardened lava with a river of molten rock still running through it. And when the eruption ends and the molten rock drains away, what is left behind is a hollow tunnel, a tube, sometimes only a meter across, sometimes large enough to walk through upright, sometimes running for kilometers through the body of the volcano, descending into the mountain in long, winding passages of frozen stone. These lava tubes are real caves, and people do explore them, crawling and walking and climbing down into the dark interior of the volcanic rock. And on some volcanoes, these tubes form vast networks, the longest of them running for tens of kilometers and descending hundreds of meters into the flank of the mountain. To be deep inside one of these is, by any fair description, to be inside a volcano, surrounded on every side by the rock the volcano made, far below its surface, in the dark, in the cool quiet of stone. So in that sense, the inside of a volcano is not unreachable at all. People go in all the time, with lamps and ropes and a sense of wonder, and come out again. But notice what these tubes actually are, and the quiet irony at the heart of them. A lava tube is a passage that the fire has left. It is hollow precisely because the molten rock drained out of it and went somewhere else. It is cool and enterable precisely because it is no longer connected to anything hot, because the eruption that made it ended long ago, because the fire has moved on and abandoned it. The lava tube is the cooled, emptied outermost plumbing of the volcano, the part nearest the surface, the part that has finished its work and gone cold. To walk through it is to walk through the dead veins of the mountain, the channels the fire used and discarded. It is the exact opposite of reaching the deepest hot interior. It is reaching the shallowest cold remains. And the tubes go only so deep, and only into the cooled outer skin, and they never connect down to the living conduit, never lead to the magma, never descend toward the reservoir or the source. They cannot, because the moment a passage reached down to anything still molten, it would no longer be a cool, empty tube. It would be full of fire, and sealed, and impassable, like everything below. The hollow you can walk through, and the fire you are trying to reach, are kept apart by their very natures. Where there is room to go, there is no fire. Where there is fire, there is no room to go. The lava tube proves the rule, even as it seems to break it. You can be inside the volcano, yes, but only in the parts the fire has left behind, never in the parts where the fire still lives. Let's go deeper still, in our minds, past the conduit, past the plug, down to the place the old picture imagined as the great chamber, the cauldron, the reservoir of fire, because there is something there, something real, that we call the magma chamber, or in more careful modern language, the magma reservoir, or the magma storage zone. But it is nothing like the cauldron of imagination, and understanding what it actually is may be the strangest and most wonderful part of this whole slow journey. For a long time, even scientists pictured the magma chamber as a kind of underground lake, a great open body of liquid rock sitting in a cavity in the crust, kilometers below the volcano, feeding it from below, a balloon of molten rock in the stone. And the words we still use, chamber, reservoir, carry that old image with them. But as the tools for sensing the interior of the earth have grown finer, as we have learned to listen to the way earthquakes travel through the depths, and to read the subtle signals they carry, A different picture has emerged, and it is far less like a lake and far more like something living and dispersed. The magma is not, for the most part, a pool of pure liquid. It is held within the rock, in the spaces between crystals, in a vast zone where solid and molten are mingled together. Imagine a sponge soaked with water, except the sponge is rock and the water is liquid fire, and most of the volume is the rock, the solid crystalline framework, with the melt filling the gaps between. This is what scientists now often call a crystal mush, a region, sometimes many kilometers across, where the rock is hot enough to be partly melted, perhaps only a tenth or a fifth of it actually liquid at any moment. The rest a porridge of crystals, slowly growing and dissolving and shifting. Not a chamber you could enter, not a cavity at all. A zone of the deep crust that is hotter and softer and partly molten, embedded seamlessly in the colder solid rock around it, with no walls, no roof, no floor, no open space, no surface, nothing a body could occupy or a vessel could float upon. Sit with that for a moment, because it overturns the entire fantasy. The deepest, hottest heart of the volcano, the source of all that fire, is not a room. It is a saturation. It is a quality the rock takes on, of being partly liquid, the way a region of cloud is not a container of rain, but a condition of the air. You could not stand in it any more than you could stand in a fog, and it is buried, depending on the volcano, somewhere between a few kilometers and many kilometers below the surface, locked inside the body of the Earth, under pressures that would crush any hollow space shut, at temperatures that would melt any probe long before it arrived. The cauldron of the old picture does not exist. There was never a door to it, because there was never a room. There is only deep rock, made strange and hot and half alive by the heat rising from below, and through it, in cracks too fine and channels too narrow and a structure too solid for anything to pass, the magma gathers and waits, and, when the pressure is right, rises. And the deeper you go, the more thoroughly the door is closed, because of something we have touched on but should sit with directly, which is pressure. Every meter you descend into the earth, the weight of all the rock above presses down a little harder, and that weight accumulates with terrible swiftness. By the time you reach the depth of a magma reservoir, kilometers down, the pressure is hundreds, thousands of times the gentle pressure of the air we live in, a crushing all directions squeeze that no empty space could survive. This is the deepest reason there are no caverns down there, no chambers, no rooms. Any hollow that tried to form at such depth would be pressed shut, the rock flowing slowly in to fill it, because at those pressures and temperatures, the rock itself ceases to be brittle and begins, over time, to deform like something soft, to creep and sag and close any opening, the way a footprint in wet mud slowly fills itself. This is the same thing that defeated the deepest drillers, the way the borehole tried to heal itself shut. Depth does not just make things hot, it makes things full and tight and self-sealing. A cavity at the surface can stand for ages, a cave, a tunnel, a tube. A cavity in the deep crust cannot stand at all. The pressure will not permit it. So even the idea of a chamber, the very thing the old picture is built on, is forbidden by the physics of the place. The depths are not just unreached. They are, by their nature, unhollowable. There is nowhere down there for an inside to be. And so the molten rock that gathers in the reservoir is held not in a room, but in the grip of the rock itself, dispersed through it, pressed into the spaces between crystals, squeezed and held until enough of it accumulates and enough pressure builds that it can force open a crack and begin to rise. The rising of magma is, in a way, an escape from this grip, the fire finding the one direction the pressure permits, upward, toward the lower pressure of the surface, toward the only release. It does not rise because it is light and free. It rises because it is being squeezed out of the deep, the way water is squeezed from a sponge, driven upward by the closing weight of the world. And when it reaches the surface and erupts and then retreats and hardens, the door seals behind it, and the deep returns to its full, tight, hollowless state, waiting in the dark under all that weight for the next slow accumulation, the next opening of a crack, the next reluctant release. This is why, when you ask why no one has reached the deepest point inside a volcano, the truest answer is not really that it is too hot, though it is, and not really that the air would kill you, though it would. The truest answer is that there is no point to reach in the way we imagine reaching it. The deepest point is not a destination in an empty space. It is a place inside solid matter, a depth within the body of the planet, no more enterable than the center of a stone you hold in your hand. To reach it, you would not have to travel. You would have to become the rock, or unmake it. And the rock will not be unmade by anything we can send. But we are a stubborn species, and the fact that a place cannot be entered has never stopped us from trying to touch it. And so, having descended in imagination as far as imagination can go, let's come back toward the surface and think about the one real way we have ever managed to physically reach magma, not by descending into a crater, not by climbing down a conduit, but by going at it sideways, from above, with a drill. Because there is a small and remarkable history here of the handful of times human beings have, almost by accident, touched the molten interior of the earth. And it is a story of surprise, because every time it happened, no one expected it. Drilling into the earth is one of those quiet, enormous endeavors that most people never think about. We drill for water, for oil, for heat. In volcanic regions especially, we drill for geothermal energy, sinking boreholes into the hot ground to tap the warmth for power. And these holes go down 1 kilometer, 2 kilometers, 3. The engineers who plan them have models of what lies below, built from seismic surveys and from other holes nearby, and they expect to find hot rock, hotter the deeper they go, but solid rock, drillable rock. And on a few occasions, in a few places, the drill has gone down expecting hot stone and has struck, without warning, magma, liquid rock, the molten interior itself, far shallower than anyone believed it could be. It happened on a volcano in Iceland, at a place called Krafla, during a project to drill deep in search of unusually hot geothermal resources. The plan was to reach down toward very hot but still solid rock, deep in the roots of the volcanic system, and at a little over 2 kilometers down, the drill suddenly encountered something it could not have encountered, according to every expectation. It hit magma. Molten rock, around 900 degrees, rose up into the borehole, a quenched glassy material flowing into the bottom of the hole. The drillers had, entirely by accident, drilled directly into a body of magma that no one knew was there, or at least, no one knew was there at that shallow depth. It was one of only a tiny number of times in all of human history that a drill has reached living magma, and it caused a great deal of excitement among the scientists, because suddenly there was a hole leading down to the molten interior, an actual physical connection to the thing we have been talking about all night. And here is the detail that matters most for our question. Even then, even with a hole drilled straight into magma, no human went anywhere near it. No one descended the borehole. No one approached the molten rock. The borehole was a narrow shaft, centimeters across, far too small for any person, and at its base was a substance that would destroy anything sent into it. What the scientists did instead was study it from above and from a distance, lowering instruments, measuring the heat, drawing up the quenched glass that the magma formed as it chilled against the cooler hole, learning what they could from the threshold without crossing it. The closest humanity has ever come to deliberately reaching into a magma body, and still, it was a matter of instruments at the end of a wire, of measurements taken from a control room at the surface, of touching with machines what no hand can touch. Something similar happened in Hawaii, where a geothermal borehole drilled into a body of magma a couple of kilometers down, again unexpectedly, again with molten rock welling up into the hole. And in Kenya, in the Great Rift Valley where the continent is slowly tearing itself apart and volcanism runs close beneath the surface, drilling has encountered the molten interior as well. Each time, the same pattern. A drill reaches what no person could reach. A narrow hole touches the fire, and the people remain at the surface, kilometers above, learning through wires and sensors and the slow, patient interpretation of signals. We have reached magma, in this limited sense, a handful of times. We have never reached it with anything but a machine, and never with anything a person could follow. These accidental encounters have given rise to an idea, a project that is, when you think about it, one of the boldest things our species has ever contemplated, even if it remains mostly a vision. The idea of deliberately drilling into a magma body to build a kind of observatory there, an outpost at the very edge of the molten interior, with permanent instruments reaching down to the threshold of the fire, monitoring it continuously, learning how magma behaves in the years and decades before it erupts. To take the accident of Krafla and repeat it on purpose, to sink a hole knowingly into the magma and keep it open and instrumented, a window into the interior that stays open. It is an extraordinary ambition, and even it, the most direct assault on the interior anyone has seriously proposed, involves no human descent at all. It is still instruments, it is still measurement from above, because the fundamental fact never changes. The interior can be touched by machines and read by sensors, but it cannot be entered by us. The deepest a human will ever go is the control room at the surface, watching the numbers come up the wire from a place no human could survive. And drilling, in any case, has its own deep limits, quite apart from heat and magma, and these limits tell us something about how thoroughly the interior of the Earth resists us, even where there is no fire at all. Because the deepest holes humans have ever drilled were not in volcanoes, and they did not stop because of magma. They stopped because the Earth itself, at depth, simply will not allow the drilling to continue. There is a famous hole drilled over many years in a cold, far northern corner of Russia, on the Kola Peninsula, where geologists set out simply to drill as deep as they possibly could into the crust, to see what was down there, to reach further into the body of the planet than anyone ever had. It was not a volcanic region. The goal was pure depth, pure exploration, and they drilled year after year through the 1970s and 80s, the hole creeping downward 3 kilometers, 6, 9, until eventually it reached past 12 kilometers, more than 12,000 meters, the deepest hole human beings have ever made. A borehole deeper than the highest mountains are tall, reaching down into rock that had been buried for unimaginable spans of time. And then it stopped. Not because they ran out of will or money, though money was always a struggle. It stopped because the rock, at those depths, stopped behaving like rock. The temperature down there was far higher than the models had predicted, around 180 degrees, hot enough that the drilling equipment struggled and the conditions grew impossible. And the rock itself, under that heat and the colossal pressure of everything above it, had become plastic, soft, flowing slowly like a thick tar over long periods, so that the hole would deform and close, the walls pressing inward, the borehole trying to heal itself like a wound in living tissue. The deeper they went, the more the Earth resisted, not with hardness, but with a kind of yielding that was worse than hardness, a softness that swallowed their efforts. And at 12 kilometers, having barely scratched the outermost skin of the planet, having reached perhaps a third of the way through the crust alone, and not even begun to approach the deeper layers, they stopped. The hole was abandoned, sealed, left as a monument to a limit, 12 kilometers. That is the furthest into the solid Earth we have ever reached, anywhere, by any means, and it is nothing, a pinprick, against the depth of the planet, whose center lies more than 6,000 kilometers down. Hold those two numbers together for a moment, gently, the way you might hold two stones. 12 kilometers, the deepest we have ever drilled. 6,000 kilometers, the distance to the center. We have reached, at our very deepest, about 1/500th of the way to the heart of our own world. And a volcano's magma chamber, the deepest part of its interior that we have been discussing all night, sits within that thin outer skin, within the crust, within the reach of drilling in a few rare cases, but everything below it, The great hot mantle, the place where the magma is truly born, lies far beyond anything we can drill, in conditions that would close any hole and destroy any tool long before it arrived. The interior of a volcano, deep as it seems to us, is still part of the surface world compared to where its fire ultimately comes from. So let's follow the fire to its true source now, because the deepest point inside a volcano, if we take the question seriously, is not really the magma chamber at all. The magma chamber is only a way station, a place where the fire gathers and waits on its way up. The fire comes from somewhere deeper still, from a place that makes the magma chamber seem almost shallow, almost close. And that place is the mantle, the vast hot layer that makes up most of the earth, beneath the thin crust we live upon, and the volcanoes are rooted in. The mantle is strange, and it is worth letting the strangeness settle slowly. It is rock, solid rock, for the most part, and yet over the long spans of geological time it flows, it moves, it churns in enormous slow currents, carrying continents on its back, the way a thick syrup carries whatever floats upon it if you stir it slowly enough. It is hot, growing hotter with depth, thousands of degrees in its lower reaches, and in certain places, under certain conditions, parts of it melt, just partly, just enough, and that melt is the beginning of every volcano. The magma that rises through the crust, that gathers in the reservoirs, that fills the conduit and forms the lava lake and glows in the crater, began its life as a small fraction of liquid squeezed out of the solid mantle, far below, and rose because it was lighter than the rock around it, gathering as it went, traveling upward through cracks and channels, over years or decades or centuries, until it reached the shallow storage zones beneath the volcano. The deepest point inside a volcano, traced to its true beginning, is down there, in the partial melting of the mantle, at depths of many tens of kilometers, sometimes 100 kilometers and more. And it is worth understanding, even drifting as we are toward sleep, just how the mantle comes to melt at all, because it does not melt easily, and the ways it does are part of why volcanoes appear where they do, in long lines and scattered points across the face of the world. The solid mantle rock is hot enough, in one sense, that you might think it would simply be liquid, but the immense pressure pressing down on it, the weight of everything above, keeps it solid, the way enough pressure can hold a thing from changing its state. So the mantle melts not by getting hotter, for the most part, but by other quieter means. In some places, where the deep hot rock rises slowly toward the surface, the pressure on it eases as it rises, and at a certain depth, the falling pressure alone allows it to begin to melt, even though its temperature has barely changed, a melting that comes simply from the lifting of the weight above. This happens where the plates pull apart, along those undersea ridges, and beneath the great hot plumes that rise from deep within the mantle to feed the volcanoes of places like Hawaii and Iceland. In other places, the melting comes from water, where one plate of the crust dives down beneath another and sinks back into the mantle. It carries water with it, locked into its rock, and as it descends and heats, that water is squeezed out into the mantle above, and water, mixed into hot rock, lowers the temperature at which it melts, the way salt lowers the temperature at which ice will melt. So the mantle above a sinking plate begins to melt, and the magma rises, and a chain of volcanoes is born along the line where the plates meet, the great rings and arcs of fire that trace the edges of the oceans. In every case, whether by the easing of pressure or the addition of water, only a small fraction of the rock ever melts, a tenth of it, a fifth, and that small fraction gathers and rises, and everything we have spoken of tonight, the reservoir, the conduit, the lake, the crater, the glow, is the long, slow journey of that small fraction toward the light. The deepest point inside a volcano is the place where this begins, tens of kilometers down, in the partial melting of rock under conditions we will never witness directly, the first faint stirring of a fire that will take years, sometimes centuries, to reach the surface, if it ever reaches it at all. And there is no reaching that, by any means we have or can imagine. We have never drilled even through the crust into the mantle, anywhere on Earth. It has been attempted. There was an ambitious project, long ago, to drill through the thinner crust beneath the ocean and reach the boundary where the crust gives way to the mantle, a boundary marked by a change in how earthquake waves travel, named after the scientist who discovered it. The project was begun and then abandoned. Too difficult, too expensive, the conditions too severe. Even now, with specialized drilling ships that can work in deep ocean and bore down into the seafloor, reaching the mantle remains a goal not yet achieved, a frontier still ahead of us. We have not pierced the crust into the layer beneath, not once, not anywhere, and the mantle source of volcanic fire lies deep within that layer we have never reached. So the true deepest point inside a volcano is not merely unreached, it is unreached by a margin so vast that the parts we have touched, the lava lakes, the occasional magma body struck by a drill, are not even close to it, are barely the surface expression of a process that runs down through the entire thickness of the crust and deep into the mantle below. This is the scale of it. This is why the simple question, why has no one reached the deepest point inside a volcano, opens into something so much larger than it first appears. The honest answer is that the deepest point inside a volcano is, in a sense, the interior of the Earth itself, and we have only ever scratched the very top of that, and even the scratching stops within the thin outer skin, and the fire we see in the crater is the visible tip of a column of heat and rock and melt that descends through everything we cannot reach, down into the great hot heart of the planet that we have never touched and may never touch. The volcano is not a thing with a bottom we have failed to find. It is a window into the depth of the world, and the depth of the world has no bottom we can stand upon. And so, unable to go, we have learned instead to see without going, and this is its own quiet marvel, worth lingering on as the night deepens. Because although no person and no machine can descend into the interior of a volcano, we are not entirely blind to it. We have found ways to sense it, to map it, to watch it move, all from the surface, all without crossing the threshold, the way you might come to know the inside of a sleeping house by the sounds it makes, the creak of its settling, the hum of what moves within its walls, without ever opening a single door. The most powerful of these ways is listening to earthquakes. Whenever the earth shudders, whether from a great distant earthquake or from the small tremors that volcanoes themselves produce as magma shifts and cracks open beneath them, waves of energy travel out through the body of the planet, passing through the deep rock, bending and slowing and speeding as they go. And the way they bend and slow and speed depends on what they pass through. Hot rock slows them, partly molten rock slows them more, and weakens certain kinds of waves, and stops others. So by placing sensitive instruments across the surface and recording, with great precision, how these waves arrive, how long they take, how they have been altered on their journey, scientists can work backward to build a picture of what lies below, a picture assembled not from light, but from sound, from the echoes of the planet's own movements, a slow tomography of the deep, like the way a medical scan builds an image of the inside of a body from waves passed through it. And in these images, the magma reservoirs appear not as sharp-walled chambers, but as soft, blurry zones of slowed waves, regions where the rock is hot and partly molten, their shapes and depths emerging gradually as more and more tremors are recorded and added to the picture. We have, in this way, seen the interiors of volcanoes, mapped their hidden plumbing, traced the crystal mush zones kilometers down, all without sending anything into them at all. We see them the way we see the inside of a closed fist by the shape it makes, the way we know a thing is there by how it changes what passes around it. And there are other senses we have given ourselves. We measure the ground itself, watching it swell and sink by tiny amounts as magma moves below. The whole flank of a volcano, breathing outward by a few centimeters when the reservoir fills, settling back when it drains, a movement far too slow and small for any person to feel but clear to instruments that can detect a shift of millimeters from satellites in space. We measure the gases that escape, sampling the breath of the volcano from a safe distance or even from aircraft and drones, and from the changing chemistry of that breath, we read the state of the magma below, because different gases escape at different depths and different conditions, and a change in the mixture can signal that magma is rising, that an eruption may be coming. We have flown small machines down into the craters themselves, drones carrying cameras and sensors into the poisoned air where no person could follow, bringing back images of the lava lakes from angles no human eye has seen, sampling the gas at the very edge of the molten surface, and flying out again, expendable, replaceable, going where flesh cannot. In all of these ways, we have built up a knowledge of the interior far deeper than our reach. We understand, in real detail, the structure we cannot enter. We can describe the crystal mush, estimate its depth, track the movement of magma through the system, anticipate eruptions, sometimes days or weeks ahead, by reading these signals. We know the inside of the volcano. We have simply never been there, and never will be. And there is something almost peaceful in that arrangement, when you sit with it. We have made a kind of peace with a place we cannot go, by learning to know it from outside, by becoming patient readers of its faint outward signs, by accepting that knowledge and presence are not the same thing, that you can come to understand a place intimately and still never set foot in it, never need to, never be able to. Let's pause here for a while and let the imagination do what the body cannot, because in imagination, there is no heat and no poison and no solid rock, and we can descend the whole way, slowly, through the structure we have built up together tonight, and feel the shape of the thing we cannot reach. Begin at the rim, in the dark, the crater opening below you, the glow at its base. Lower yourself in your mind, past the loose ash walls, down through the swirling gas, down toward the lake, the heat rising to meet you, the roar growing. Reach the surface of the molten rock, the crusted plates drifting and splitting, the brighter orange beneath, and stop there, because this is the deepest any living thing has ever come, and let yourself float just above it, untouched, as no one ever could be. Now sink through the surface, into the liquid column, into the conduit, the molten rock all around you, hotter and denser as you descend, the pressure mounting, the light fading from orange to a deep, dull red, to darkness, as the glow is swallowed by the depth. Feel the conduit narrow, the clean liquid thickening into mush, more crystals, less melt, the passage dividing into cracks and channels, finer and finer, until there is no passage at all, only hot rock threaded with thin veins of fire. Pass into the reservoir, the great crystal mush zone, kilometers across, a saturation rather than a space. The rock and the melt mingled together, no walls, no room, just a region of the deep crust made hot and half alive, and keep sinking, down past the reservoir, down through the solid crust, kilometers of it, deeper than any drill has ever gone, the rock growing hotter and softer, beginning to flow in its slow geological way, until you reach the boundary, the place where the crust gives way to the mantle, the boundary we have never crossed with any tool, and cross it, in imagination, into the mantle itself, the vast, hot, churning body of the planet, solid yet flowing, thousands of degrees, and find at last, somewhere down there, many tens of kilometers below where you began, the place where the fire is born, where the mantle rock partly melts and the first drops of magma gather and begin their long rise toward the surface. That is the deepest point inside a volcano. That is the source. And you have reached it only here, only now, only in the mind, drifting toward sleep, because there is no other way to reach it, and there never has been, and perhaps there never will be. It is worth asking, as we drift, why this should be so. Why is the inside of our own planet, the ground directly beneath our feet, so much harder to reach than the surface of the moon, than the bottom of the ocean, than the cold, far edges of the solar system? We have gone outward so much further than we have gone inward. We have crossed the vacuum of space, which seems the very image of impossibility, and yet that emptiness turns out to be, in a way, hospitable. It is cold, it is airless, it is hostile, but it is empty, and emptiness can be crossed. A vessel can carry its own air and its own warmth, and move through the nothing. The interior of the earth is the opposite of empty. It is the most full place we know, packed solid, every space closed by pressure, every cavity crushed shut by the weight above, and fullness cannot be crossed. You cannot carry a bubble of survivable conditions into solid rock. You cannot float a vessel through stone. The very thing that makes space crossable, its emptiness, is the thing the interior of the earth most completely lacks. And so the direction of our reaching has been, in a strange way, decided for us by the nature of the medium. We go where there is room. We have flooded outward into the emptiness above, and downward into the water, which, though dense, is at least a fluid that can be entered and moved through. But the solid depths beneath us remain almost untouched, because solidity is, for a body that needs space to exist in, a wall in every direction at once. The deepest point inside a volcano is closed not by a single barrier we might one day overcome with a better suit or a stronger machine, but by the fundamental fact that it is not a place with room in it, that to be there would be to occupy the same space as the rock, and two things cannot occupy the same space, and that is a law deeper than any technology. There is a humility in this that I find strangely comforting, and perhaps you do too, in the quiet of the night. We are a species that has grown used to the idea that there is nowhere we cannot eventually go, that every frontier yields to enough effort and ingenuity, that the unreachable is only the not yet reached, and mostly that has been true. But here, directly beneath us, closer than the nearest city, closer than the clouds, is a place we cannot go and likely never will, not because we lack the courage or the cleverness, but because the universe has arranged matter in such a way that this particular place is simply not enterable by anything like us. The center of a stone, the heart of the fire, the deep, full, hot interior of our own world. We can know it, we can map it and measure it, and read its slow movements and predict its eruptions. But we cannot stand in it, and there is a kind of rest in accepting that, in letting one thing remain genuinely beyond us, a place that does not need us to enter it to be fully itself, glowing and churning and breathing in the dark, indifferent to whether we ever arrive. Think of all the people, over the long history of our curiosity, who have given themselves to getting as close as they could to this unreachable place. The volcanologists who have spent their lives at the edges of craters, who have walked across cooling lava and stood in the poisoned air and lowered themselves into pits, learning the volcano by living near its mouth. Some of them gave their lives to it. There were two, a husband and wife, who spent their years together traveling the world to be near eruptions, who filmed the lava and the ash and the great explosive clouds from closer than almost anyone dared, who loved these mountains with a devotion that is hard to fully understand from the outside, and who died together at last in the path of a sudden burning cloud rushing down a slope, taken by the very thing they had spent their lives drawing near to. There were others, scientists watching a mountain they knew was about to erupt, who stayed at their posts to record what happened and were lost when it came. The history of getting close to the interior of the earth is written partly in such losses, in the lives of people who understood the danger completely and went anyway, not recklessly, but because the desire to know, to see, to be near was stronger in them than the fear. And even they, the closest of all, never reached the deepest point. They reached the rim, they reached the crater floor, they reached the edge of the lake, and they paid, sometimes, the highest price for reaching even that, the very threshold, the doorway, the surface of the world we cannot enter. There was a time, not so very long ago, when no one knew whether it was even possible to descend into an active crater and live, and there were those who found out by trying. In the middle of the last century, a handful of pioneering volcanologists began deliberately lowering themselves into the pits of active volcanoes, down toward the lava, when no one had done it before. when there were no proven methods and no specialized gear, only rope and nerve, and an overwhelming desire to see the fire up close and bring back knowledge of it. One of them, a tireless and famous figure, spent decades climbing down into craters all over the world, standing at the edges of lava lakes, filming them, describing them, insisting that the only way to truly understand a volcano was to go to it, to be near it, to look into its open mouth. His accounts unsealed the interior of these mountains for countless people who would never go themselves, who would only ever know the fire through the eyes of those willing to climb down toward it. Over the years, the gear improved. The explorers came to wear suits coated in reflective material, silver and gleaming, designed to throw back the radiant heat, suits that let them stand a little longer, a little closer, than bare cloth ever could. They carried their own air against the poison. They rigged better ropes, learned the moods of the craters, mapped the descents that had once been blind. And with each passing generation, they got a little nearer, a person at a time, on a rope, in a silver suit, breathing from a tank, lowering themselves toward the glow. And that, when you trace it all the way down, is where the record stands tonight. The deepest any human being has ever gone inside a volcano is not the achievement of some vast machine or grand expedition. It is a single person, suited and roped and masked, standing on a ledge in a crater, beside a lava lake, at the very surface of the molten world, having gone as far as living flesh can possibly go, and not one step further, because the next step is into the fire, and the fire does not allow it. Everyone who has ever tried to reach the deepest point inside a volcano has stopped in the same place, at the edge, at the surface, at the threshold, beside the lake, and never in it. And there they have stood, in the heat and the roar and the poisoned air, as close to the heart of the earth as anyone will ever come, looking down into a depth that begins exactly where they end. There is something in that devotion worth carrying with you toward sleep, I think. Not the danger, not the loss, but the depth of the wanting. The way human beings will give so much to draw near to a mystery, even one they know they cannot solve, even one whose final answer is forever out of reach. We do not study volcanoes only to predict eruptions and protect the towns below them, though we do that, and it matters. We study them also because we cannot help ourselves, because there is a fire at the heart of our world, and we want to be near it, to understand it, to feel the warmth of a thing so much vaster and older and hotter than ourselves. The reaching is its own reward, even when the destination can never be arrived at, perhaps especially then. There is something else worth holding on to as the night deepens, and it is the matter of time, of how slow all of this truly is. We picture volcanoes as sudden things, all eruption and violence, fire in an instant. But the eruption is only the briefest flash at the end of a process so slow it defeats the imagination. The magma that bursts from a crater in a single dramatic night may have begun as the faintest melting deep in the mantle thousands of years before, may have spent centuries rising through the crust, a little at a time, gathering in the reservoir, waiting, cooling and reheating, growing and shrinking as more melt arrived from below, all of it unfolding over spans of time longer than human memory, longer than the oldest of our stories. The fire we are trying to reach moves at the pace of the earth, which is to say, almost not at all, by the measure of a human life. A person could stand watch over a sleeping volcano for an entire lifetime and see nothing change at the surface. And yet far below, in those slow years, the magma would be shifting, the crystals growing, the pressure inching upward, the whole hidden system breathing on a rhythm so vast that a single breath might take 1,000 years. This is part of why the interior stays so close to us, in a sense beyond the physical. We are quick and brief, and the volcano is slow and almost endless. Our whole civilization, every city and every story, occupies a sliver of time, so thin that the magma beneath a single volcano might not complete one full cycle of its breathing within it. We arrive, we look, we wonder. We lower ourselves a little way into the crater on our ropes, and we are gone again. our whole lives passing in less time than it takes a body of magma to make up its mind to rise. The mountain does not notice us. It cannot. We are too fast and too small and too short-lived to register on its scale. And the deepest point inside it, the slow gathering fire far below, has been there, doing what it does, since before there was anyone to ask about it, and will go on long after the last person to wonder has fallen silent. To reach into it would be not only to cross heat and rock and pressure, but to reach across that gulf of time, into a process that moves to a rhythm we can barely perceive, a fire that is, in every sense, deeper than us. And the volcanoes themselves go on, indifferent to all of it, to our reaching and our studying and our longing. Long before there was anyone to wonder about their interiors, they burned, through all the ages we spoke of on other nights, through the long reigns of creatures now turned to stone, through the slow drift of the continents and the rise and fall of seas. The volcanoes were there, the same process, the same rising fire, the mantle melting and the magma gathering, and the mountains breathing out their poison and their light. They are among the oldest ongoing stories on the planet, older than oceans in their current shape, older than the continents in their current arrangement, a process that has run without pause since the earth was young and molten all the way through. And they will go on long after us, long after anyone remains to ask why their depths were never reached, breathing and glowing and building and destroying, the fire rising and the rock sealing the door behind it, again and again, in the patient, endless rhythm of a planet that does not know or care that it is being watched. When you next see a volcano, even only in a picture, even only in the mind, perhaps you will hold a little of this with you, the knowledge that what you are looking at is the smallest visible part of something immense and hidden, the tip of a column of fire that descends through the entire crust and into the mantle below, into depths we have never touched and cannot touch, that the glowing lake at the bottom of the crater, dangerous and beautiful and roaring, is not the interior, but only its surface, only the threshold, only the place where the inside meets the outside for a moment before plunging back down into the unreachable dark. That every volcano is a door we can stand before but never open, a window we can look through but never climb into, a mystery we have come to know intimately precisely because we can never enter it. We have mapped its plumbing without seeing it. We have measured its heat without touching it. We have read its moods in the trembling of the ground and the chemistry of its breath and the slow swelling of its flanks. We have flown machines into its poisoned crater air and drilled a handful of times, by accident, into the very edge of its molten body, and learned what we could from the threshold. But no person has ever descended into the fire, and no person ever will, because the deepest point inside a volcano is not a place with room for us, not a chamber or a cavern or a hollow waiting to be found, but a depth within the solid, hot, full body of the earth itself, sealed by pressure, defended by heat, hidden in the rock, born in the mantle far below everything we have ever reached. It is one of the last truly closed places on a planet whose surface we have almost entirely opened. And maybe it is good that something remains closed. Maybe it is good that the heart of our own world keeps its fire to itself, glowing on in the dark beneath us, reached only by our imagination, touched only by our wondering, as it has glowed since the beginning and will glow long after we are gone. And so we come, slowly, to the end of tonight's wandering. We have stood at the rim and looked down into the glow. We have descended in imagination through the crater and the gas and the lava lake, down the narrowing conduit, into the crystal mush of the reservoir, through the solid crust deeper than any drill, across the boundary we have never crossed, into the mantle where the fire is born. We have learned why no person has reached the deepest point inside a volcano, and found that the reasons run deeper than heat alone, deeper than poison, down to the simple, unyielding fact that the interior of the earth is too full and too closed and too vast for anything like us to enter. And we have found, perhaps, a kind of peace in that, in the existence of a place we can know without going, a fire we can love without touching, a depth that does not need us and never will. If this slow journey has been a comfort to you tonight, if it has helped to quiet the mind and ease you towards sleep, you might let the channel know with a gentle like, or stay with us by subscribing, so that more of these calm explorations can find their way to you and to others looking for something soft to carry them into the dark, but only if it feels right to you. There is no hurry here, and there never will be. For now, thank you for spending this time with me, for letting your thoughts sink down toward the hidden fire and rise again, unhurried, toward rest. Wherever you are, whatever the hour, I hope the night is kind to you. Let the world grow quiet. Let your breathing slow. Let the deep, warm heart of the planet go on glowing far below you, sealed and safe and unreachable, while you, up here at the surface, in the soft dark, let yourself finally rest. Sleep well, and may your own depths, the ones that no one else can ever quite reach either, be gentle with you tonight.